The next point of call is our workshop inductions. To be able to work in the workshop facilities at RMIT, first thing we need to do is we need to make sure we're inducted within those spaces. Again, part of this is going to be a bit tricky for those of you who are not in the country at the moment. For those of you who have already done your workshop inductions last semester or the semester before, fantastic. You don't need to go back and do them again. But there's two fundamental things we need to have completed before we can access the workshops. The first one is this general safety test. Okay, the general safety test is something that takes place online. You access it through the workshop's website, which is where we are right now. So obviously I've clicked on that hyperlink that I've put in the week 1 modules, and then clicked on the test, and it brings me into here. Essentially what it is, it's a 3-part questionnaire with multiple choice questions. So what you need to do is you need to work through each of these sections, read the material, and then you'll continue the test. The page will then prompt you to log in. Okay. In this case, I haven't had to log in because I'm already logged into the system, and it's a series of multiple choice questions. Okay. Answer the questions. Once you've answered all the questions, move on to the next part of the test. Okay. It's 3 parts. Once you've completed the test, it will ask you to submit. Hopefully you've got all the questions correct, and you can move on. Really important that you get at least this general safety test done before you get into classroom environments where we're going to be using the workshops. Because especially at the end of the semester, and even the mid-semester when we start to use the laser cutters, vitally important that you can access the workshops, because that's where the laser cutter resources reside. The other part of it is that you'll need to do a workshop safety induction. Workshop safety inductions are held on campus Mondays, 9:30 to 10:30, Building 100, Level 1, which is a workshop. Okay, so obviously you need to be on campus to be able to attend those. Only once you've done the safety induction and the online quiz are you able to access workshops freely. Okay, so once you get into the country, really important that you attend one of these. They run them each week on the Monday, and complete those inductions. Just whilst we're here, this website is really useful, okay, the workshop's website, because it gives you an overview of their opening hours, the sort of machinery they have, who has access, and some of the other resources they have. You can look at, for instance, 3D printing and see these are the specific 3D printers that the workshops have. You can see that the Zortraxes aren't here, and that's because the Zortraxes are handled specifically by industrial design. You can also see the modelling lasers, which we will be going into a lot more depth in week 6, as these are the resources that we're going to be utilising. These are actually open access, so you don't have to go through a technician like you do with the Zortraxes. You get to do some training, which we'll do in class, and then you can come and use these at your leisure. There are also some other laser resources which are handled by the Laser Bureau for doing more substantial work. What I mean by that is cutting steel or cutting thick materials and larger scale materials, and these are handled by workshops and workshop technicians. Okay, so really important that you complete the training. As I said, week 1 modules, jump on the inductions, drop in here, and you'll see what's going on. Okay, general safety test, make sure you do that one online, shouldn't take you very long, and then have this one booked in and ready to go when you get into the country. Okay. Typically here I take you for a walk around Building 45. Bit difficult again to do that. Essentially Building 45 is a series of classrooms. We have a main sort of communal area. We have one computer lab, which is where we're undertaking this class. And then we have the Building 45 workshop. The Building 45 workshop has a lot of our sort of hardcore digital fabrication tech. So that's where our CNC milling tends to take place. We've got a HOMAG CNC router. We've also got a BSE CNC router. We've got the Haas 3-axis It's actually a 5-axis mill, and that's where our Metabeam and our OmniBeam lasers are. Also got a CNC brake press, which is a Trumpf TrueBend, and a range of other machinery. Typically, the only things that you guys will be needing will be the modelling lasers. You may need the Metabeam lasers, which are in Building 45, or the OmniBeam, and in rare cases, some of you may do some CNC milling. Okay, so that's a brief sort of introduction of the course and sort of some of the things that you need to be across before you land. Before we jump into the next section of the class, I want to have a chat to you about the first assignment. Okay, so the first assignment, essentially what I've found by teaching this course for several semesters is we need to establish a baseline of understanding how to draft and model in a three-dimensional environment. So essentially when we look at objects such as these, okay, they have been modelled in some sort of three-dimensional software, okay, exported as a file, and then printed by our Zortrax printers. Okay, so what we find is that because this is a master's program, there's a lot of students coming from a range of different disciplines, and a lot of you will have used different CAD software. Some of you may not have used CAD software. So I've decided that what we need to do is bring you up to speed with a piece of software called Fusion 360. Okay? If you have experience in other software, I'm happy for you to use that. But if you don't, Fusion 360 is what we're going to be covering in the first few weeks of class. We'll go into more depth about why I've chosen Fusion 360 later. But for all intents and purposes, it offers great capability, but also a reasonably easy learning curve. It's reasonably straightforward and logical to get you up to speed as fast as possible. Okay, so the first assignment is going to be based around essentially your skill set that you develop using Fusion 360. So you're going to be doing a 4-minute presentation of your work, which is essentially going to be an exhibition of your Fusion 360 or other homework activities. So you need to document your process and outcome with respect to the objectives you have 3D scanned or modelled in the preceding weeks. In class, we do a 3D scanning experiment, which is essentially more to sort of indicate what's involved with 3D scanning and why it's not necessarily the best way to go with this course. If you are interested in doing that, I would suggest that you visit the Clone, spelled with a Q, website. Here it is. You'll need to print one of these mats, which looks like this. And then once you've printed that mat, okay, you can use this app, which will allow you to do a 3D print. It's quite straightforward, it's quite understandable, all right? But for the intents of the course, we won't be really delving into 3D scanning beyond this, unless you specifically want to. And there's various reasons for that, namely, scanning is one thing, being able to edit that scan data and clean it up can be very time consuming and quite difficult. That's essentially a whole course worth of work right there, okay? So if we come back to our assignment, what I'm looking for is I'm looking for you to show me some models that you are going to generate using Fusion 360. So you're going to generate a parametric CAD model, a freeform CAD model, and an assembly CAD model. Again, this will become clearer to you once we delve into Fusion 360 what I'm talking about. But essentially, parametric modeling is the underlying interface and structure of how this CAD software operates, okay? And it offers a really streamlined way of modeling in a very logical manner, okay? So a parametric model, a freeform model, and an assembly model. That's what you're going to be delivering for the first assignment, okay? It's important that you show me how you got there, what you tried, what didn't work, what you changed so that it did. I also want you to show me how you added complexity and used more features of your chosen package, and then I want you to show off your outcome. Remember, the greater the complexity and the use of CAD functionality, the better. Okay? Remember, this is presentations no more than 5 minutes. 3 to 4 is perfect. We'll get you to upload your presentation to Canvas. Okay? Make sure you bring a copy of it with you and give it some sort of naming convention that makes sense. The way I want you to name it is your student number, and then your name, and then the course, and then your assessment. In this case, it's assessment 1. Okay? So make sure that you have it, you refer back to this when you're preparing, and also have a bit of a look at the rubric. Okay? Essentially, the way it's judged is each model and then your clarity of communication, and they're all weighted equally. So essentially, if we're offering 100 points, then each of these is 25.